Hello, now we are working with part 3 of 9.1 exponential functions notes. If you look towards the bottom of your old notes, we're looking at example number 2. Now we're going to go over a way that we can write an exponential function. Let's look at the problem that we're given. It says the figures below are stages of the Sierpinski triangle. In stage 0, there is one black triangle, and each subsequent stage, a white triangle is being added to the center of each black triangle, dividing that triangle into 3 small black triangles and 1 white triangle. The number of black triangles increases every single time by a factor of 3 in each stage. So let's look at this very carefully. Already it's telling you something very important. It gives you a key feature right here. Stage 0. This word here is so important. At stage 0, there's only 1. That should kind of trigger a part of a vocabulary word. This is what we call an initial value. Initial value will represent our A in exponential function. Also, the word factor down below should also trigger something. That is when you're multiplying by something which in our equation represents our B value. So very important, but I would like to translate my images into a table to kind of refresh our memory of what was done in the previous example. So let me go ahead and zoom in a little bit on the side here. I'm going to create a table, a horizontal table on the right to interpret the triangles that are given here. So I'm going to create a horizontal table. The first is my X and the bottoms are my Y. The X are going to represent my stage numbers. And the Y values are going to represent the number of those black triangles. So we have the number of black triangles. Okay, so let's look at this. Stage 0, how many did we have? We had 1. Okay, stage 1, we ended up having 3. At stage 2, we have 3, 6, 9. Are you noticing the pattern? You noticed before it said a factor on the previous piece, factor of 3. So that means you're multiplying each Y value by 3. So our ninth one the third one should have 9 times 3, which is 27. And stage 4, try to squeeze that in there. When you multiply everything, you should get 81. And just verify. Do 1 times 3, 3. 3 times 9. 3 times 3, 9. 9 times 3, 27. And 27 times 3, 81. Okay. So let's go ahead and answer the question below. It says, write an exponential function, f of x equals a b raised to the x power to describe the situation. Okay, let's rewrite my function. I'm going to go ahead and rewrite it here. Okay, remember f of x is really y, it's the same thing. And we're going to substitute our values that go here. We're going to go ahead and substitute our a and our b. Well, what is our a? A, if you recall, is your initial value. Okay, that is your a. So what is our initial value that we began with? And that's your 1. That is your y value right there. So 1. Okay. And what is your b? B is your factor, your ratio, your common ratio. In this case, what am I multiplying by? We were told that we have a factor of 3. So even within the problem, it told us the a and the b values. Your next piece is just to substitute your information. Okay, your function is your a, which is 1, times your factor, which is 3, raised to the x power. Again, we do not write the 1. It's understood to be there. So f of x equals 3 to the x power. And this is your equation in factored form. Exponential form. Our next piece is asking us to determine in what stage, there will be more than 1,000 black triangles in our problem. Well, we could estimate, we can go ahead and start looking at numbers to make a prediction of what it could be for the next stage, or kind of make a rounding or prediction of what our next stage. For example, stage 5, what could stage 6 look like? Okay. So again, you can select techniques such as estimation and mental math to solve this problem. In stage 2, you notice how there were only 9 black triangles, round 9 to 10, and then multiply by the factor of 3 to make that estimate of the number of black triangles in later stages. Okay, so let's go ahead and try some estimations. Okay, so let's predict. Let's go ahead and assume, let's see, a number. Let's find out when x is a 6, which is my stage number, and determine how many black triangles I would have. Okay, so let's go ahead and find an x value, and right now I use 6, when y is greater than 1,000. Okay, again, y represents the number of black triangles. So if I want to find, if I know that x is now 6, and my base, my factor, the ratio, it happens to be 3, now my 6 is going to be up here, which represents my exponent. So now my x is no longer x, it's actually 6. So if I raise 3 to the 6th power, means 3 multiplied 6 times, so it'll be 3 times 3 times 3 times 3 times 3 times 3 is going to give you a total of 729 triangles. Okay, so that's still not greater than 1,000. So let's try a next stage. Let's try 7. Again, you have 3, which is your factor, and I'm raising it to a new x, which is my 7. When you multiply all that out, you get 2,187. So at stage 7, there are more than 1,000 of those black triangles there. So it cannot be 6.5. There actually have to be integers between 2, 3, 4, 5, 6, and 7. So at stage 7, we actually had more than 1,000. Okay. Again, hopefully you're having a good day, and stay safe and make good choices.